So take out your notebooks. We're going to jot down some little notes about function notation. It's nice. You may have seen it already, but I'm going to break it down for you. You guys remember y equals 3x plus 2 is a linear equation?
Yeah.
Or a linear function?
Yeah.
Yeah? Remember those days? So when we wanted to evaluate, when we wanted to find y, a y value for a given x value, we would say, plug in x equals 3. We would say, if we plug in x equals 3, we get, this is 9 plus 2. So we can do like an xy table here and say when x is 3, y is 11.
What's t?
Stop it. So, yeah? No big news? Okay, so here's what we're going to do. A guy named Leonard Euler came up with this thing called Euler notation, or function notation, where he said instead of writing y equals stuff, we can write f of x equals stuff. And the way we pronounce this is f of x. Or some people even say f at x. Right, so f is the name of a function. It's a generic, like you guys remember the sine of x and the cosine of x and the tangent of x? Those trig functions? Yeah. So f is just a generic function. Right, it's not a specific, so we get to define it. I'll say f of x equals, and I define it whatever I want my function to do, quadratic, linear, whatever. So this does not mean f times x. This is not f times x. No. Bad. No. Don't ever tell me f times x. That's not what's happening here. It's more like f of x. It's kind of like it's like a vending machine, right? So f of x is like this kind of. It's like this box. It's like a vending machine, and you put in some money and you press A2, and then the Skittles come out. Yeah. So there's an input and an output. So this is like your input slot. You put things into that. Yeah? So this is a function. So you have, you put stuff into it. Say f of x. So input, you put x's into it. X is your input. And stuff comes out of it. Y is your output. And then we'll start eventually talking about things, all of your possible x values that you can put into a function is going to be called your domain. So take note. That domain is any possible x value that you can plug into a function is your domain. And then the range is all of the possible values that can come out of a function. So your vending machine example, your input, your domain would be like, you press the buttons like A5 or B7. All of those different combinations of stuff you could press, that's your domain. And your range is Skittles, crackers, Cheetos. Squirrels, yeah, things like that. You never know what's in the vending machine. I'm trying to think of I was in Switzerland. I was in Zurich, Switzerland, and they had funny vending machines. I'm trying to remember what was in there. I think they had like marijuana tea or some like weirdo stuff. I was like, whoa, this is weird. Or they had like panties or something. I was just like, what?
That's Japan.
I don't know, but I remember they had weird vending machines. Is that a thing in Zurich? No. Okay. No. Okay.
They have a makeup vending machine at the airport.
Yeah, they have a lot of weird vending machines.
Yeah. Is it good makeup?
Anyway.
Yes.
So. Good stuff. That good, expensive airport stuff. Okay, so let's get back to this f of x is 3x plus 2. So now instead of me saying I want to know what the function value, I want to know what the y value is when x is equal to 3, here's what I do. I just say f of 3. And I know that this means plug in 3 into my function. So then wherever there was an x, I'm going to plug in a 3. And this is 9 plus 2 is 11. So you could turn this table here, instead of an xy table, it can be an x and f of x. So f of x is really y in disguise.
It's y with one of those glasses.
Yeah, with the nose and the mustache. It's really just y. But it's convenient because you can plug the x value into this.
We'll see.
We'll see. Okay, we'll see. So we can do this. We can say, hey, what is this function? So here's my function definition. You define your function, and then you use that function however you please. But so we could say, hey, what is f at 0? So this function f, when I plug in a 0, is 3 times 0 plus 2.
Dose. No, wait.
It's what?
Dose.
Dose. So when I plugged in an x of 0, I got a function value of 2. Yeah? Yeah, eventually. I mean, not this one. I mean, just an example. But so input, output, right? So let me put some more examples up here. Are we good so far? Any questions? Cool.
Oh wait, okay, so do we come up with whatever we want to plug it in just to make the chart, or is he going to tell us like what to put in?
Yeah, you can make up your own. Usually I'll do like -1, 0, and 1, or whatever. So here's a function. X divided by 4 plus 2. And you can just make up function names like g of x or h of x. Real creative. Yeah? You like that?
Or r of x.
Whoa, I didn't think of that one.
Yeah.
So g of x is, I don't know, x squared minus 2. Right? We can just make up functions.
You're just making stuff up now.
We're just making stuff up.
So I can say f of 4. Connell, can you evaluate this function at 4? So that means plug in a 4 wherever the x is and holler back.
Okay. You want me to do it?
Do it.
Okay. The x in the fraction or the numerator will be, numerator, right? So it'll become 4. And 4 over 4 will become 1. It's plus 2.
Is what?
Equals 3. Yeah.
Hallelujah. This man evaluated a function.
Woo!
Right? So you guys know the word evaluate means give me a value for. So when you evaluate a function, you're going to get a number out of that deal. So, how about, who shall I call on now? How about Alexa? G of 3. Evaluate the function g.
Okay, so you put g where the x is, so it's 3 times 3 is 9. And minus 2, so equals 7.
Awesome sauce on a sesame seed bun. Now Renee, hot shot, what's g evaluated at -3?
Oh, it's the same thing. 7.
So we're going to plug a -3 right here.
I'm right, so.
So I'm gonna do this.
Yeah, then it becomes positive.
Does anyone know why I put parentheses around my -3?
Because you can't.
Owen?
So to attach the negative to it, like.
Yeah, because here's a funny thing. If anyone has a calculator and they type this in,
Wait, I can't.
there's a very good chance that it's going to tell you -9, which is a lie. Lies. It lied right to your face.
I think it just makes it.
It lied!
It told you -9?
Yeah.
You know -3 times -3 is +9. Why would it lie to
It
you?
gave me 9.
It gave me 9.
Mine
Yeah?
Wait,
Oh, yours is honest.
I got 9.
Did you use parentheses?
Nope.
Really? Okay. So it depends on what calculator you have, which means you have to use your brain at all times. Because you might type something in a calculator and it tells you something, you go, oh, I have an answer, and you write it down, it's totally wrong. Right? People do that all the
It
time.
doesn't attach the negative sign.
Right, so your calculator does, please excuse my dear Aunt Sally. Do you remember old Aunt Sally? We have this thing, Sophie, the order of operations
So you're gonna.
Oh, you called it that?
that
It's
says,
called PEMDAS.
do you know this?
No.
Okay, so when we're evaluating something, first we do parentheses, and then we do the exponent, and then you do multiply and divide, and then you do add and subtract. You have to do it in that order. And the acronym, we say this is please excuse my dear Aunt Sally. You
We just call it PEMDAS.
You just call it PEMDAS?
No, please excuse my guilt fast sweat.
Sixth grade.
Okay.
PEMDAS. Yeah, Miss PEMDAS.
PEMDAS.
So anyway, right, parentheses, exponents, multiply, divide, add, subtract. Anyway, where were we?
Multiply, subtract, bring down.
Aww.
Divide, multiply, subtract, bring down.
Okay, so bring it back. Bring it back to me.
Yeah.
So this, dear Aunt Sally, what's dear Aunt Sally going to do with this?
She's gone.
Is there any parentheses?
Nah.
No. Is there an exponent?
Yes.
Yes. So it's going to apply this exponent. It's going to do 3 squared, which is
9.
9, and it's going to say, oh, hey there, fella, and it's going to see a negative sign. And then it's going to say, oh, -9, but this is wrong. Lies.
I mean, it is right because it is put parentheses on it.
Yeah, so anyway, if you put parentheses around it, so 9 minus 2, 7. Crazy. How about, let me think. How about, this is fancy. Who wants to get fancy? Owen, you want to get fancy?
Sure.
So how about, I'm going to say g of x is equal to -1.
Okay.
What is x?
You got your meat, huh?
0.
Is it? How would you know?
Because it's not there.
I don't know if that's
Okay,
valid.
wait.
Fancy.
So what x could I plug into this function that would give me -1?
Any. Well,
No.
only 0.
X times 0.
So 0
No.
minus 2?
Only 1.
1? 1 squared is 1. Minus 2 is -1.
Wait, are we?
Oh, you're still using that one?
Yeah, this function. Yeah, g of x.
Oh, I thought that was like the actual.
The only way you could do that squared, okay, you need to get 1. So 1
One?
squared minus 2 is -1, yeah.
So for the function to equal -1, we would need to plug in x equals 1.
Yeah,
Are there any other solutions?
-1.
Or -1?
Yeah,
Fancy.
that's why you do the plus and negative when you have.
Yeah. Anyway, so this is function notation. So it's not anything new. You guys have seen functions before. You guys have seen y equals 3x squared plus 1. You guys have seen y equals x minus 4. Have you guys seen absolute value of x?
No.
Yeah.
You know, plus 1 or something. What other? You've seen square root functions? Y equals square root of x plus 2, you know, or something like that. These are all functions. But now we're just gonna do this. Instead of saying y equals, we're gonna go, whoa, I'm fancy.
I'm fancy.
You gotta hold your pinky out. Because it's fancy. Yeah? And it's a new kind of notation. So, you are going to practice using this new notation